So welcome to the session team. Greetings to everyone. So I'll start with the session now. So the agenda today is we are going to see about continuous integration in LabVIEW projects and how the workflow we are envisioning and how it helps the team to develop further and how to integrate it with Azure DevOps to continue. Okay. So coming to the first thing, right? Like many of us will be wondering, like, what is continuous integration? So to just give an heads up, right? Like continuous integration is a software development practice in which the development teams will make changes, very small changes, and then try to integrate with the main and get it get the feedback, like whether the feedbacks, like whether that is the code whatever that is being made is working good and high quality, and then it will be merged with the main. So it's like it will address the integration issues quickly, and it allows the team to have the development process more smooth and efficient, right? So now we have a question, right? Like why we need an integration, continuous integration, right? So the main thing why we need is it will give a faster feedback loop and early detection of issues, and it helps in saving cost as well as the time which we spend in understanding the integration issue and coming, right? And it also helps in supporting for agile practices. Okay, so now we can see like what are the main elements in Azure DevOps and that helps in implementing this continuous integration and CD, right? So as you see here, this is the general software development practice we see. So the developer will be sitting there, and then he just need to make some changes based upon the new functionalities that has been requested. So we have a source code control where the code is actually hosted now. So and then the developer will access the source code and make this sufficient changes to the source code, whatever that he needs. And once all the changes are made, then we will build the tool, build the application, test the application, and we will analyze the reports that has been formed, and then we will release, right? So instead of doing this, what we are going to do is we are going to automate this and reduce the manual efforts. And to do that, we are going to use like a few elements. One is actually the source code repository, which is the code where it's source. And the second one is orchestrator, which is nothing but a service that will monitor this source code and trigger these tasks, right? Like I need to build, or I need to test, or I need to analyze the report of the tool. So this will take care of triggering that. And then we will have a few of the pipeline definitions. Pipeline files are nothing but those file will consist of the list of actions that need to be taken on the source code upon a change. Let's say I need to build, so that is the change request, and it will have the list of tasks there. And agent is actually the worker which is going to do this operations, like it is going to take the code from the source code, build it, and it is going to take the code and test it and report, right? And artifacts are nothing but the test files which are generated when the agent is working on these activities, and it will be retained in the output of the pipeline file, right? So now moving on to the typical workflow. So if you take the Git workflow, we have the individual developers, and the source code has been configured with proper pipeline files and the proper analysis, like static code analysis or unit tests and other things has been configured. And now a new request comes in, and the developers start taking a new branch from the source code, and he starts working on that, and he is making he or she are making a commit into the Git, right? So now what happens? The orchestrator will always be polling the Git repository, and it will get like something got changed, and based upon the triggers, it will start executing the pipeline as you see here. And once the pipeline has been executed, there will be various tasks under the pipeline, like we can see like build, test, or run static code analysis, all those things, right? So all those things will be dedicated to individual agents, And once all those items got completed, all the agent has tested or performed these operations, the results will be notified to the architecture again, and it will be published to the developers. So the developers will get an instant feedback upon what the quality of the code and the functionality of the code, and whether they have made any changes that is affecting the existing the existing code in the main, right? So this is a closed feedback, and we are getting whatever we make, we get an immediate feedback. So we will see now what are the things that are available for setting up this framework in a LabVIEW project. The first thing is a source code repository, and for a demo that is coming up, we have used Azure Repos Git itself to host our code models. And the second one is a static code analysis. So as a team, we will constrain with certain regulations and design considerations within our team, and we would have been aligned with some coding standards. So all those coding standards are converted as a VE analysis test, like user-specific VE analysis test, and that has been integrated with the code. And we also have a dynamic code analysis, like nothing but a unit test that is written for functionality testing. And here we have used Caraya UTF for the demo purpose. And the deliverable, like we build SD out of the code which is tested, and that. Right. And coming to the Azure side, so the architecture is like Azure DevOps service, and the agent is we have created a self-hosted agent, which is just a PC with all the dependencies installed, and the agent has been hosted in that PC. And we also have created a pipeline file and a CLI mechanism to trigger this VA runs from the thing. So now I will quickly jump into the demo. I will quickly show like how the code is. So if you see here, hope you guys are able to see the Azure portal, and we have a demo repository, and we have a main branch. I'll quickly show the contents of the main. So if you see here, the actual source code resides here, and for demo purpose, we have created some minor improvements. Like if you can see, like this is a basic VA, which does some arithmetic operations like addition, subtractions, and things based upon the user selection. So it will just simply do some calculation and give a result, right? So what we did is, in order to like always ensure that this code is not affected, we have done two things. One, write a unit test for that. Like if you see here, we have created a lot of test cases for that, constituting what is the expected behavior. And if we run this, so it is using that VI to pass these informations, and it is testing like these are all the expected results, and it is matching with all the things. So the results is getting passed, right? So now this is the dynamic test, like functionality test. And for static code analysis, we have created a VI analyzer test configuration, and we have created a runner VI, which is going to like run this static config for all the VIs that got changed. So both of the things are configured in the Azure pipeline file. So if you see here, we have triggered like whenever some things got changed in the main, this will be triggered, and we can see like it is running the VV analyzer first, and then the unit test second, right? So that is how the pipeline configured. So now, as you see, the main is in good state, and we can see like the VV analyzer is also passed, and all the unit test is also like success, right? So now, as a developer, I have a change request like to add a document or something. So without this continuous integration architecture within the team, we will just make the changes to the main, and it will be reviewed, and the main have a high risk of getting broken, or it can be like not getting deployed easily, right? But now, after we have integrated all this CI things, now we will see like how it's preventing the user to make unwanted changes or functionality issues. See here, right? So what I'm doing is I'm just creating a branch called demo, and what I will do, I will quickly check out to the branch. And my intention is actually to add a documentation work, like it's not very clear. So to add a documentation to this particular VA. So what I'm doing is I'm going here, opening this VA. Let's say I'm just adding some documentation. Uh, right, and instead I also like made some unknowingly I made changed some sub VAs or some node. So I just replaced this with some other nodes. Let's say, let's assume that was the mistake I did. So now with this changes, what will happen is all the models that is depending upon this sub VA for this particular case will get a improper results constituting to like a major failure, right? So now I just made a change and I'm closing it, and I'm just pushing the changes to the actual report, right? Added documentation. So now I have made the change, and we can see like I assume that I added documentation, and I am just raising pull requests for it, right? Like looping in people to get some reviews and feedbacks. So that is done, and I'm creating a pull request. So immediately when I do it, you can see that under the PR we can see like some things started running, right? So this is actually it started to run vanalyzer and unit test for this particular code change that I did. So if I quickly want to see it, maybe I will navigate to the agent and show. So this is the agent PC, and it's been waiting to see any operation, and continuously it will wait on to get any tasks. And currently we can see like it started running the VA analyzer. So we can see like the LabVIEW is getting instantiated, and we are seeing like it's starting to run the VA analyzer code. Since we have made only change to one particular VA, so it started checking that, and then that all the test whatever we have loaded is getting loaded, and it's now tested. So yeah, this is the VA which I changed now. So we can see like that VA is getting now analyzed, and it completed the test. Yeah, and then we were able to see like the agent has been configured as to publish all the VA analyzer results as an RSL file and HTML file, and what are the modified file. So we can at any time instance we can download and see what is the actual change that has been done. Now we have started running the unit test. So we can see like the subtract test cases are failed because I have changed unknowingly, and because of this, this unit test is getting failed, right? So what happens is the unit test gets failed, and because of that, the entire pipeline is getting failed, and we will not be able to merge this until I fix this code, right? So instantly, was able to like when I make a change, I was able to get an instant feedback using this approach. So with that, I am restricting, like I'm making sure that always the main has been updated properly, and all the code whatever we goes into the main is always like made sure that it's perfect, and it's making all the code changes functional, right? So we can see all the failure cases, so we can easily go and fix this, right? So this is how like in our LabVIEW projects we can implement CI and prevent making a high time to do integration test and things, right? And I just added a references, like we can go to learn.ni.com and see how continuous integration process using Azure DevOps. It is a detailed session on how to integration. this. And we can also, you can go to YAML schema from learn.microsoft, and you can see how we can code a pipeline file and deliver like hard tasks and things. And we also have, I have just attached like the links which I use, like one is the Caraya UTF to run the unit test, and GCLI to trigger this unit tests and runner VAs from the pipeline file to the actual LabVIEW environment. So with this, we will close and hope everyone will have a great learning in accessing this and then getting a good workflow built for their team. Thanks, everyone.